have number 4. Assuming the activation energies are equal, which of the following reactions will occur at higher rate at 50 degrees Celsius? So we have, okay, so we have NH3 plus HCl, ammonia and HCl, and also we have trimethylamine, and it's nitrogen bonded to 3 methyl group. So assuming we have the same activation energy. Okay, so we have, right, in this problem, we know that activation energy affects, okay, the reaction rate. If we have higher activation energy, then we have lower reaction rate, lower rate. And if we have, but but in this problem it says that it has the same, okay, same energy of activation. Okay, so uh, given that these molecules have the same energy of activation, the same, so we cannot identify anymore who has higher rate and who has lower rate because they have the same. Now let's go to the temperature. We have temperature. Okay, also that we know that the temperature affects the reaction rate. If we have higher temperature, we have low higher, okay, we have higher rate. Okay. And then also it says that it's 50 degrees Celsius. So they have the same temperature also. Okay, so in this problem, we cannot determine who is faster because in temperature because they have the same temperature. We cannot know that one by just looking at the temperature because the temperature is the same now. Okay. So what else? What can we determine pa? They have the activation energy, we have the temperature, okay, the collision. All right, we know the collision is directly proportional to temperature. If higher temperature, higher rate because of higher collision. Collision fraction. Okay, we have higher collision. So we will try to look at the mass. Okay, let's try to look at the mass. Uh, Mass also affects the rate of reaction because if the same repetisyon, if we have uh, tambok o niwang, so the niwang runs faster than the katong tambok. So we can apply that in our molecule too. We can, alright, determine who is faster by looking at their mass. Okay, so the mass, who has a higher mass here? NH3. Okay, NH3 has, okay, let's calculate the mass of NH3. Okay, so the mass of ammonia NH3 is 17 atomic mass unit, while for the trimethylamine is, let's calculate that, 114 plus carbon, the carbon has 12 and it's 3, so we have 50 plus how many each? We have 9 plus 9. Okay, so atomic mass is 59 atomic mass unit. Okay, so we can see that uh, ammonia has, ammonia is lighter than trimethylamine, so it's heavier. Okay, notice that in this problem we can't be because they have the same activation energy. and they have the same temperature, so we cannot rely on that on those two variables in determining who is faster because they are the same. Now, but also here the mass also can affect who is the rate of the reaction. So we know that lighter molecules move faster than those heavier ones. All right? So we can now explain that this molecule, the trimethylamine, the nitrogen bonded to three methyl groups. This molecule is heavier, so it moves slower, and it has a slower rate of reaction than the ammonia, who is a lighter molecule. Okay, so let's write that one here. And also, wait, also this one, the trimethylamine is bonded to three methyl groups: methyl, methyl, and this one, methyl, the CH3. Okay, note, I've told you that there are times that the collision is not successful. Okay, sometimes collision is not successful because of the orientation. Okay, orientation of the molecules. So we have this NH3 and this one bonded to HCl. Because of the bulky group, because it's very complex to look, but just looking at it, it's complex now. So because a molecule spin, right? It spins when it moves. Okay, it spin and then it bounds to HCl. Sometimes the H may collide to the CH3 group, which is not possible. Which is it's possible, but it could not lead to successful collision because the H here in HCl must collide. Okay, H here must collide here. The nitrogen. Okay, in nitrogen, the lone pairs here. It must attack here. It needs to collide in the nitrogen. But because this one, trimethylamine, is very big, so it spins and spins, there are times that the H group in HCl may tend to collide in the CH3 group, maybe in H, particularly in H, which is not successful, which is not good. So it cannot lead to successful collision. Only it can lead to successful collision if it collides to the N group at the center, and it's ano na lisod na kay magtuyok-tuyok the molecule spin. And okay, there are times na dili siya niya maabot, di should makakolide ang HCl sa nitrogen group here. But here, the HCl can easily attack the or collide the nitrogen group here because it's gamay. Gamay man siya. Okay, so it can easily attack to the N group here. All right, I'll write that one. So we have two factors here: the mass, and then we have the structure. Okay, structure. All right. So the mass, ammonia has lighter mass, and so it moves faster per joint. And also the structure of this trimethylamine is very complex, so there are times that the collision is not could lead to not successful one. Okay, I'll write that one, huh? So here, at the same temperature, both reaction mixtures have the same average kinetic energy, but the reactant molecules do not have the same average velocity. The trimethylamine molecule has greater mass than the ammonia molecule, so trimethylamine molecule will collide less often with HCl. Moreover, the bulky groups bonded to nitrogen and trimethylamine mean that collisions with HCl having the correct orientation occur less frequently because it needs for the collision to become successful, it should be in correct orientation. And therefore, the rate of reaction between ammonia and HCl is higher. Okay, so ammonia should has higher rate of reaction than the trimethylamine. Okay, because in the again in this problem, it's equal in activation energy and then equal in temperature. So, ato na lang kung ano is its mass and the structure. All right, that's all.